Hello and welcome to the third video in the SAT Math series. In this video we're going to cover some algebra basics that we'll need to know for the rest of the course. If the pace of this video is too fast for you or you want a more extensive review, please be on the lookout for the Algebra Fundamentals series that I'll do after this one. If the pace is too slow for you, good. It looks like you are ready for more advanced concepts. First, a quick review of the distributive property. Notably that multiplication distributes over addition. For instance, in this first expression here, x times the quantity y plus 2. To simplify this expression, you must multiply x by y, and then add that to multiplying x by 2. Therefore, this is equal to the following. When you are attempting to simplify an equation, here we perhaps want to multiply both sides of this equation by 5 to simplify the 5 on the bottom of this fraction. Multiplying the left by 5 will simply cancel the denominator. But on the right-hand side, we see that the 5 must distribute over the plus sign. And therefore, the right-hand side will be 5 times x plus 5 times 2, which is 10. Here is an easy SAT problem. It says which of the following is equivalent to the expression, and if you know that you can distribute this, then you quickly get the answer with a few steps of algebra. Or answer choice C. Now let's do a quick review of combining like terms. We'll kind of over-explain on the first problem and then really quickly do two more problems. In this first problem, we see that it reads, the expression above can be written in the form ay squared plus b, where a and b are constants. What is the value of a plus b? First, we note there's nothing being multiplied by this parenthesis here, so these parentheses are not necessary. There's nothing to distribute in. In the second case, there is a 10 to distribute in here, so we can first drop the initial parentheses on the first expression, and we can distribute in this 10 here, getting the following. Then we see that we have two terms here that are like. They're like because they both have a y squared, and then we have two constant terms. So combining like terms, these two are going to be 200y squared. And these two terms here are going to combine to become 6432. Then we see that the problem reads, we need to find a plus b, where a must be 200 and b must be 6432. This gives us a grand total of 6632. Okay, so combining like terms was the point here, and you can see that in this step. Doing two more problems very quickly. You can distribute in this negative here and simplify this algebraically to the following. And then again we have combined like terms here, or answer choice A. And again we have another problem asking you to simplify the expression or find an equivalent expression. Again here we see a negative needs to be distributed in. So the first order of business would be to distribute that negative, basically flipping the sign of everything. And here we see it's still combining like terms, just the terms have more variables. We have a x squared y and an x squared y. That would be a 2x squared y. There's two of them. We have a negative 3y squared and a positive 3y squared. That's a nice 0. And we got a 5xy squared and a negative 3xy squared for a grand total of 2. xy squared, or answer choice C. Next, let's recall that you can do the same thing to both sides of an equation, and the equation will still hold true. For instance, this problem reads, what value of t is the solution of the equation above? And in this case, to get t by itself, we want to get rid of the 2/3 in front of it. You could do this in 2 steps, but you can also do it in 1 step by multiplying by the reciprocal of 2/3, which is 3/2. But you must also multiply the right-hand side of the equation by 3/2. This will simplify to a 1, and 1 times t will be t. And then the right-hand side of the equation, you will multiply across, and therefore t will be equal to 15/4, as fractions multiply across the numerator and denominator. The next problem reads, a bricklayer uses the formula n is equal to 7LH to estimate the number of bricks n needed to build a wall that is L feet long and H feet high. Which of the following correctly expresses L in terms of n and H? So we want to isolate L, and L is here. To isolate L, we probably want to divide both sides by 7 and divide both sides by H to get it by itself. I'll do that in one step, dividing by 7H. And we see that L must be equal to n over 7H. Lastly, number 32 will kind of combine the distributive property, combining like terms, and performing the same action on both sides of an equation. So here we see that we have two distributions, and again, there's a -1 here, we could think, or the negative will distribute. The first distribution will be 10x minus 40. The second one will be minus 15, and then minus 8x, and that is all equal to 7. Now we combine like terms. The 10x is like a negative 8x. 10 and negative 8 is going to give us a 2x. And then we have a negative 40 and a negative 15 will combine for a negative 55. Now, to get x by itself, we don't want to divide by 2 yet because you'd have to divide the entire left-hand side by 2, and thus it would distribute over this minus. So it makes sense to add 55 first to both sides. Like so, and you would get 2x is equal to 62. Dividing both sides by 2 now will give x equal to 31. So hopefully this is familiar to you. Real quickly, let me again iterate. If the pace seems too fast for you, please check out the series on fundamentals that is soon to come. Let's now have a look at another manipulation you're able to make, and that is you can multiply the top and bottom of a fraction by the same thing. In this case here, we have a problem that reads if 7/9 x minus 4/9 x is equal to 1/4 plus 5 over 12, what is the value of x? And we see here that these have the same denominator, that is a 9, so we are able to subtract these and get 3/9 x, but on the right-hand side, these do not have the same denominator, and thus these fractions can't be added yet. To make them the same denominator, we can multiply the top and bottom of this fraction both by 3. And so that looks like this. 1/4 becomes 3 over 12. And then further simplifying, 3/9 is of course 1/3. And 8 over 12 is actually 2/3. So this is 1/3 x is equal to 2/3. And multiplying both sides of this equation by 3 will give you x equal 2. So let's see a slightly more complicated example of multiplying the top and bottom of fractions by the same thing. Here, in the last one, we simply did it to get a common denominator here. But in this case, it reads, if x is greater than 3, which of the following is equivalent to, and then we have this long expression. Well, this is a fraction over an expression that has two fractions. So when we multiply the numerator and the denominator by the same thing, we can either do it to the large fraction or to one of these small fractions. However, if we do it to the large fraction, for instance, let's multiply the top and bottom by x plus 2, because we'd like to clear this denominator by multiplying by x plus 2. So of the larger fraction, x plus 2 times the top, and x plus 2 times the bottom, you're going to get x plus 2 on the top here. And let's see what happens with the bottom. In the bottom, the x plus 2 will multiply by this and distribute over this plus, right? When it multiplies by the first expression, it simply cancels the denominator and you're left with a 1. Then, when it multiplies by the second expression, there's nothing to cancel. It just multiplies by the numerator, and you get x plus 2 over x plus 3. But then again here we have a weird case where we have a fraction over a fraction, but we'd like to clear this denominator by multiplying it by x plus 3. So again, for the larger fraction, the bigger fraction, the one defined by this symbol here, we multiply by the numerator by x plus 3, and the denominator by x plus 3. And again, we see that the x plus 3 will distribute over this plus. Now, we're going to cover foiling in a future video, but suffice to say that you need to FOIL this here in the numerator and get x squared plus 5x plus 6. Admittedly, it's a rather difficult problem for a review section, but it does well illustrate the multiplying the top and the denominator by the same thing. In the denominator, again, we distribute the x plus 3 over the plus. Multiplying the x plus 3 times the 1 will give x plus 3. And then multiplying the x3 by this expression will simply cancel the denominator, and you'll be left with x plus 2. Then, the denominator has like terms to be combined. And we arrive at answer choice B. Definitely a difficult problem for a review, but again, illustrating how powerful, how we need to have this skill of multiplying the top and bottom of a fraction by the same thing. Next, let's do a quick review of functions and composed functions. Function notation looks like something that you have here, where you have a mapping from x to f of x. Evaluating this at, say, -2 means we plug in a -2 everywhere there would be an x, being cautious with the negatives here. And therefore, we see that f evaluated at -2 would be equal to 9. A composed function is when you stick a function inside another function. For instance, number 10 here reads, a function f satisfies f of 2 is equal to 3, f of 3 is equal to 5. A function g satisfies g of evaluated at 3 is equal to 2, and g evaluated at 5 is equal to 6. And then it asks you what is the value of f of g of 3. Well, this can be easily understood if you were to understand that we have a few values of these functions, but not very many. For instance, for function f, plugging in 2 gives you 3, as this says. Plugging in 3 gives you 5, as this stated. And you do the same for g. Plugging in 3 into g gave you 2, and plugging in 5 gave you 6, from these two facts here. So you can see that g of 3, you evaluate g at 3, you get 2. So this is the same as asking of what is f of 2. And here we see f of 2 is 3. And you can see that if you simply understand the notation and understand the composed function, that it's very easy to get this problem correct. So hopefully a lot of that was reviewed to you. If not, you can check out the Math Fundamentals videos where I go over those topics a little more slowly. In other videos, we have factoring, foiling, inequalities, ratios, percent, fractional amounts, exponents, square roots. But this video was just to make sure that you understand many of the fundamentals that we're going to need for those videos. I am going to break, say, chapter 3 here into a two-parter and just do a real quick video on transforming expressions to match other expressions, just because it's such a commonly tested SAT concept. I assure you that video won't be nearly as long. So stay tuned for that.